All right, David Gish here. Just want to go over a little bit of an overview for Chapter 4 in Statistics. This chapter is over basic probability, so let's take a look at it. Now, many of you kind of know there's lots of different parts for probability. You've probably done a little bit in high school or maybe in another class, but these are kind of the concepts of the chapter. Those bottom two are crossed out. Those are in Chapter 4. We are not going to be covering those. At least most instructors won't cover those, but some instructors might talk a little bit about each of those, but generally speaking, we're going to stick to these top couple concepts. So let's just run through real quick, give you an overview, show you some quick examples, and call it a day here. So I think everybody kind of tends to know probability. You get a fraction, and then that fraction is a percent, and a percent as a decimal, it would be a value between 0 and 1. Of course, 1 means certain, 0 means possible, and then you got kind of likely or unlikely on the scale over here. So most people understand that. Now, if we want to do theoretical probability, that's in theory, you kind of know what's happening. So, for example, if I'm playing a game, in theory, I know all the possible outcomes. I know all the different cards that are in this game. I know, I'm rolling a die, let's say, and these are all the possible outcomes on rolling the die. It can't be anything other than that. So, in theory, I know everything that can happen. So, that's theoretical probability. Anyhow, count the total number of possible outcomes. That's always the bottom number. That's the total, the whole, right? Fractions are always the part over the whole. And so that's the bottom number. Then count up all the ways your event can happen, and then you just divide the two. Now, this notation here is just the probability of E. This does not mean P times E. This is probability notation. So keep that in mind. This is not a formula over here. All right, so that's it. Now, if it's empirical, which is what it's going to be most of the time for us, because we are collecting data. We don't know in theory what's going to happen. That's why we go out and collect data. That is called empirical probability. Empirical means data. And so when we do that, you collect the data, state the frequencies, and then the relative frequency is the probability. So the frequency for your event divided by the total in your sample. All right, and that would be the relative frequency or empirical probability. So here's an example of that empirical. Here's a survey about some people's impressions of the 2000s. Now, you guys many of you were probably pretty young, but in the 2000s, we had the market crash. So a lot of people, if you were to ask them, hey, that decade, probably not very positive. And so, in fact, based on this survey, if I was to ask somebody their opinion, what's the probability if they said positive? Well, there are 406 out of 1504. That works out to about 27% roughly. So that would be roughly the probability that we would estimate somebody having a positive opinion of that decade. So I was in college for most of that decade, so I had a pretty positive opinion. But I also did start work at the tail end right when the market crashed. And that was not exactly fun, but anyhow. All right, next part of probability is kind of taking it up a notch. And the first thing you kind of learn is the addition rule, which is when you have an or problem. What's the probability of this or that? And there's two ways that can happen. So we can have non-overlapping events. So like if I have a deck of cards, what's the probability of a jack or a king? Well, you can't be both at the same time. So these don't overlap. And when that happens, you can just straight up add the two fractions. Now, if they overlap, the problem is you double count something. So like a jack or a spade. And if you know cards, there is a jack of spades. So if I count up all my jacks, there's 4 of them. If I count up all my spades, there's 13 of them. So if I just added these, I actually would have double counted this. So you subtract off the overlap, all right? And there's one card in the overlap, and so if I subtract that off, that gets me the correct answer, all right? So that's or probability, so that's something you'll work with. Here's an example of that in a empirical sense. That last one was theoretical, because it's a deck of cards. Here we have some data from some blood donors. And so, hey, what's the probability you're type O or positive? All right. Now, notice I didn't say what's the probability you're O positive. If you're O positive, that would be 156 out of 409. All right. I said type O or positive. And so you would add, but you can see here in the table, these two things actually overlap. So RH positive, I got those flipped, but it doesn't matter. It's addition, so who cares? But the number of type O's is 184 out of 409. RH positive, 344 out of 409. And then there's 156 in the overlap, so you subtract that off. Remember, when you add fractions, you keep the common denominator. So anyhow, you work that out. Roughly 91% according to this. All right. Okay. Next rule then. So that was addition. You do that with OR probabilities. The next thing is multiplication. And just like with addition, there's non-overlapping and overlapping. With multiplication, that's an AND problem. And either the events are what we call independent or dependent. And if they're dependent, that means one affects the other. So when you go to do the second probability, you have to take that into account. And it's a multiplication though. If they're independent, you still multiply, but because they're independent, one does not affect the probability of the other. And so then you can just straight up multiply, no problems. So let's see two quick examples here. All right. So we're going to select some cards from a deck. What's the probability of selecting a king and then a queen? So yeah, if I take a king and keep that, there are 4 kings out of a possible 52. Now that I have that king in my hand, by the way, I'm not replacing it, right? So since I didn't replace it, that changes the probability for the queen because there's not 52 cards, there's now 51. So there's still 4 queens, but out of 51 cards now. So this one was dependent on the fact that I already took this king. So multiply that out, there you go. So really, really low probability of that. And again, this is a theoretical example. Another example here where they're independent. I'm going to toss a coin and roll a die. What's the probability of getting ahead and rolling a 6? Well, the coin has no effect on the die. So these two things are completely independent. And so just straight up multiply, you're good to go. So 1/2 times 1/6, 1/12, there you go. And so those are the couple of things. There's a few other things in the chapter as well. So like conditional probability, there's the at least once rule and a couple other little things. But these are kind of the big main concepts here. And this is just to give us a foundation so we have a better understanding of probability when we go into chapters 5 and 6.